Hi, everybody. Hello, and welcome to our discussion today on how we integrate sustainability into Amazon Web Services silicon design. I'm Paul Mazurkowitz. I'm a senior principal engineer in hardware engineering in AWS, and I work closely with the AWS Global Sustainability Team and our Annapurna Labs on the sustainability of our silicon devices. I'm joined today by Kamran Khan, one of our senior technical product managers in the Annapurna group, and David Chaikin, the chief architect at Pinterest. Before we talk about hardware, let's start with some foundational topics first. First, let's talk about what's contributing to climate change. There are gases in our atmosphere that regulate the amount of heat that is retained from sunlight shining down on the Earth. Too much or too little of these gases will change the average surface temperature around the world. Over the last 50 years, the science of studying Earth's climate has advanced to the point where we know how much of these gases have existed in the atmosphere even millions of years ago with great accuracy. For example, we can examine ice cores taken miles deep in places like Antarctica, and we can look at trapped air bubbles in the ice and basically understand how the atmosphere has changed over time. So basically what's happening is over the years, the ice builds up at a known rate, and we can bore down and take these cores out and actually check the atmospheric composition of the bubbles, again, even millions of years ago. So the graph on this slide here shows the natural variations of carbon dioxide over the last million years. And I want you to notice how the amount goes up dramatically with the start of the Industrial Revolution on Earth. So as the levels of carbon dioxide and other greenhouse gases build up in our atmosphere, weather patterns are going to change. The most obvious change, which we are already seeing, are hotter temperatures around the globe. These hotter temperatures can cause ocean levels to rise and storms to become much more intense. And this can result in more intense tornadoes, thunderstorms, and hurricanes. In some areas, the shift in weather patterns will mean less rain, which can lead to drought in those areas. And as the ocean heats up, hurricanes will be more intense in places where they have typically formed, and we may see hurricanes in places where they have not formed before, as an example off the west coast of the United States. Because of this shifting weather, species are at risk, crops can become difficult to grow in areas where they once flourished, and we can start seeing food scarcity in some areas. So it's really easy to see why we would want to take climate change really seriously. So how do companies develop sustainability strategies that address impacts of climate change? Well, Amazon co-founded the Climate Pledge with Global Optimism in 2019 to build a cross-sector community of companies, organizations, individuals, and partners that are working together to address the climate crisis and solve the challenges of decarbonizing our economy. The Climate Pledge is a commitment to reach net zero carbon emissions by 2040, which is 10 years ahead of the Paris Climate Agreement. Scientists tell us we actually have a limited window to make unprecedented headway in order to limit global warming to 1.5 degrees by 2050. No one company or organization can do this on their own, and everybody has to do their part. Businesses do not operate in a vacuum. So to drive collective cross-sector action on the climate crisis, Amazon co-founded the Climate Pledge based on the conviction that global businesses are responsible, accountable, and able to act on the climate crisis. So our public stated commitments with the Climate Pledge are to be net zero by 2040, and to be powering our operations with 100% renewable energy, which originally we committed to 2030, but we're now on a path to meet that target actually by 2025. So the Climate Pledge is open to all companies who want to commit to achieving net zero carbon by 2040. And the three principles for joining are regular reporting. So you can see we want to measure and publicly report our greenhouse emissions across scopes 1, 2, and 3. And I'll talk about what those scopes are in another couple slides. Carbon elimination, so we want to implement decarbonization strategies through innovations in our products. And finally, we want to use credible offsets to neutralize any remaining emissions with quantifiable, real, permanent, and socially beneficial offsets to achieve our net zero goals. Over 375 organizations have taken the climate pledge. As of September 2022, the signatories are in 34 countries and 54 industries. Nearly 13% of the signatories are in transportation, aviation, and logistics, which sends an important signal that there'll be rapid growth in demand for products and services that help reduce carbon emissions in these particular sectors. So carbon emissions are basically divided up into 3 scopes. So scope 1 emissions are direct on-site emissions. So this would be like power that companies generate on their own, right? And so scope 2 emissions are the result of electricity that organizations purchase for their own use. AWS is addressing our scope 2 emissions through our continuous focus on increasing efficiency in all aspects of our infrastructure. And Kamran's going to talk about that in his section. And also through our progress in empowering our operations with 100% renewable energy, and we plan to achieve that goal again by 2025. So to meet Amazon's climate pledge commitment to reach net zero carbon by 2040, we also have to reduce a very broad category of emissions called scope 3 indirect emissions. And these are emission sources that we don't necessarily own or control, but are still the result of our business operations. Now, every business has these, right? So things like employee travel and office supplies would fall under scope 3 emissions. So AWS is focused on reducing our indirect emissions associated with building our data centers and manufacturing our hardware. But today, we're just going to talk about the carbon footprint of our hardware. So there are 2 types of carbon footprint associated with our hardware. Again, one is during the use phase. So this is the carbon emissions associated with powering the hardware in our data centers. And again, as a reminder, that's scope 2 emissions. The second type is embodied carbon, which is a combination of all the greenhouse gases emitted in the production of our hardware. For example, energy and materials are needed to extract materials out of the ground, and then we need to refine those materials. Those refined materials are then processed into the components that we put into the computers that are in our data center. So inside of AWS, we have teams that study the embodied carbon associated with the different components in our hardware, and I work pretty closely with those teams. We've discovered that the highest amount of carbon actually comes from the silicon-based devices in our products, including processors and SSDs. So why do silicon devices have such high embodied carbon? Well, to understand why, we have to talk about the entire life cycle of a silicon device, like a processor or an SSD. And so it all starts with mining very, very pure quartz out of the ground. So contrary to popular belief, silicon devices are not actually made out of sand. Then what we do is, because quartz is made out of silicon dioxide and we want pure silicon, we have to combine it with a very pure form of coal, which is made out of pure carbon, to basically get the silicon crystal. So you can imagine, as we take that oxygen off, it combines with the carbon, and we end up with pure carbon dioxide as a byproduct of making pure silicon for devices. Of course, the energy that's required to actually do this and the emitted carbon dioxide are both part of the embodied carbon footprint of these devices. And lastly, we cut the we cut the crystal into thin wafers and prepare it for the chip making process. The chip making process is actually very complex. It involves 10 or more steps that are similar to old style photography in how they work. We use a special grating called a mask, and we basically shine light through this mask onto the coated wafer to make a picture of a layer of the circuitry. We do this over and over again to make the layers that a silicon device is made out of. Some of modern silicon devices can actually have over 100 different layers. And this is a very energy and materials intensive process. You could see on the slide that I've marked 2 of the areas blue. Those are very materials-intensive steps, right? Where we're depositing material on the surface of the wafer, and the etch process, where we're using a blend of gases to basically help form the picture of circuitry on the surface of the wafer. The really energy-intensive part of this process is the EUV litho process. So that's extreme UV light is what we're shining through the mask, and lithography is basically the process of exposing our image. So it's a combination of the energy used to make the chips and the materials that are used to make the chips that contribute to their overall carbon footprint. So the path to sustainable silicon involves all parts of the product lifecycle. From the raw materials to the chip fab, every step must be changed in the future to ensure that only renewable energy is used and that the materials are more sustainable. We also have to continue to increase efficiency in the manufacturing process itself. So increasing the use of sustainable energy and sustainable materials is also essential to minimizing waste in a circular electronic life cycle. So in addition to achieving Amazon's goal of powering our operations with renewable energy, we are also focused on increasing the use of renewable energy across our entire supply chain, which will help reduce, again, the embodied carbon in our hardware, that Scope 3 footprint. It's also important to ensure that our energy use is as efficient as possible. Even when energy is generated by renewable sources, the energy grid has a finite capacity, and energy must be carefully used for maximal effect. So at this point, I'd like to invite our Senior Technical Program Manager from Annapurna Labs, Kamran Khan, to come up and share with you how we basically design energy efficiency into our custom silicon devices. So Kamran.
Thank you. Thank you very much. Hi, my name is Kamran Khan, Senior Product Manager for AWS Machine Learning Acceleration Products, Inferentia and Trainium, designed by Annapurna Labs. We are the AWS team that builds hardware and software to solve some of our customers' most demanding challenges. I wanted to share a little bit about the ways we're designing purpose-built silicon across all aspects of our infrastructure and compute. And while we're talking, I wanted you to keep a central theme in mind, that we want our users to be able to do more with fewer resources and less energy. At Annapurna, we focus on the key areas that are strategic in enabling customers on AWS with purpose-built chips targeting a wide variety of use cases. The Nitro product line focused on optimizing networking, storage, and security on all EC2 instances. Graviton is our general purpose, high performance, low cost compute product line. And Inferentia and Trainium are focused on pushing machine learning workloads on efficiency and scale. With Nitro, by offloading networking, storage, and the hypervisor into purpose-built silicon, this revolutionized the cloud because it allowed us to deliver higher performance, lower cost, and improved performance per watt. And ultimately, our customers' carbon footprint when deploying their applications on AWS. Now let's continue to focus on Graviton, Inferentia, and Trainium, and let's start with Graviton. Our goal with Graviton was to build host CPUs that deliver the best price performance while keeping our power under control for a wide-ranging number of applications. Our AWS global infrastructure is built on AWS's own hardware, which includes purpose-built servers, networking, and processors optimized for our customers' workloads. One example of how we build hardware with sustainability in mind is Graviton 3, which is our third-generation ARM-based processors. Graviton 3-based Amazon EC2 instances use up to 60% less energy for the same performance than comparable Amazon EC2 instances, while delivering higher performance and new features like DDR5 and the best price performance. As a result, Graviton processors have been widely adopted by many customers looking to improve cost and deliver higher performance while reducing their infrastructure carbon footprint. Customers like Twitter, Epic, and F1 are all benefiting from higher performance applications using Graviton, while using Graviton being able to do more in fewer, more efficient instances. After the success of Graviton, we started looking at what we could do for machine learning. Now, machine learning can be divided into two parts, training and inference. In the training phase, data scientists aim to produce prediction models using large data sets. Now, training models can get very complex, but today we're going to keep it simple and keep it simple. Training models is extremely compute and memory intensive. And inference is the process of running live data points through the trained model to output predictions that can be used in a number of different use cases like natural language processing and computer vision. When we started to look at how we want to deliver better ML solutions to our customers, we wanted to start with inference. AWS Inferentia was introduced in 2019 with 3 goals. Deliver the highest performance than what was available today with traditional GPU instances, lower inference costs for our users, and of course, make it easy for them to do this with native integrations with leading frameworks like PyTorch and TensorFlow. To achieve these goals, we had to build our first ML silicon optimized for inference acceleration. Doing this not only helped us improve performance and lower costs, but delivers better performance per watt over GPU instances, allowing our users to do more with less. Even though Inferentia has only been available for a short time, we've seen amazing momentum. Here at reInvent, we're sharing their stories across many sessions, but I wanted to highlight a few here as well. Airbnb was able to double their inference throughput on their models to support their models used to power their community support hub using Inferentia. Finch Computing was able to lower their inference cost by 80% for their language translation products. And most recently, Amazon.com moved to Inferentia, reducing their inference cost by 85%. These customers are choosing Inferentia for a variety of reasons, but performance and cost are at the top of that list. In this example of BERT, a popular transformer-based model used in many language-based applications today, Inferentia can deliver 2.5 times higher performance and up to 84% lower cost over one of the most popular AWS instances for ML inference, G4DN. And while performance and costs are great, I bet you're asking, how does Inferentia impact sustainability? So I'm glad you asked. As we spoke about earlier, we want to do more with less and on more efficient hardware. Starting with the latter, Inferentia instances are more efficient, using 54% less power than G4DN instances for running ML workloads. This is because Inferentia was built for one purpose, ML inference. So it's highly optimized and tuned for this task. Next, Inferentia delivers higher performance, allowing you to do more in fewer resources. Let's look at an example. Say we're building our own real-time document understanding application that needs to extract text and images from a number of different documents and highlight relationships. We can use a transformer model to do this. However, while they deliver highly accurate results, they're very compute intensive. So we will need to use an instance that will be able to accelerate ML inference. And we have a lot of documents to process in real time, so we'll need to achieve a target throughput of 1 million inferences per hour. Of course, the throughput requirements will vary from customer to customer, but this is a good average for our example today. So if we take our application and we want to deploy it to if we wanted to deploy this application to G4DN, it would require 33 instances to achieve our target throughput of 1 million inferences per hour. If we take the same workload and we deploy it to Inferentia, we can achieve the target throughput in just 6 instances. This is over an 80% reduction in instances required. Higher performance on Inferentia means we can deploy this workload with fewer instances, consuming lower total power. A side benefit of this reduction of required instances, management of these instances also becomes much simpler. So in summary here, what we see from this, our example of document understanding, we're able to reduce the number of instances we need by over 80%, lower our energy use by over 90%, and lower our inference cost by 90% as well. This example illustrates how Inferentia's higher performance, combined with its better performance per watt, can help ML applications be greener and more sustainable while reducing inference costs. Now, switching gears, let's talk about training models. As we spoke about earlier, training models is a very compute-intensive task. And as models get bigger and more complex, we need to rethink how we're training our models. We took what we learned from when we started with our first ML accelerator, Inferentia, and applied them to training, building Trainium, an easy-to-use, high-performance training chip we launched a couple of months ago. We have built Trainium according to 4 guiding principles: optimize the system for high training performance, innovate to provide the lowest cost to train, ensure our customers find it easy to use and fast to adopt, and deliver power efficiency to help our customers reduce their carbon footprint. While we're still early on our Trainium journey, we are already seeing strong adoption from customers and key partners like PyTorch. Customers like Magic and Helixon are leveraging Tier 1's performance and innovations like new data types, double the dedicated network bandwidth, or hardware-optimized stochastic rounding for training of their next-generation AI solutions. Tier 1 delivers 1.5 times higher throughput compared to GPU-based P4D instances, and also reduces the cost to train by 50%. As models grow larger and more costly to train, researchers can use the cost savings to train faster, iterate more, and train larger models under the same cost budgets. Let's look at an example, similar to what we did with the inference example. In this example, we're going to be training a BERT large model. Without getting in too much into the details, these models require a lot of compute and time. The longer the model takes to train, the more power and money it consumes. Traditionally, this could take weeks or months using a single instance. To accelerate this, data scientists typically deploy these jobs to a cluster of ML accelerators. If we deploy this training job to a cluster of GPUs on P4Ds instances, it will take about 13 hours to train this model. On the other hand, using a cluster of Trainiums with Tier 1 instances, we can train this model in just about 5 hours. That's 2.6 times faster. And because Trainium can complete this training job in less time, it reduces the energy consumption by half. And also, we reduce the cost to train this model by 75%. This is just an example, but what's exciting from a sustainability perspective is that AWS Trainium is able to help users train models faster while reducing costs and energy use. Oh, I lost the one. As machine learning becomes a larger part of the products and services we consume, the growing compute required to fuel them is often seen at odds with reducing energy and sustainability goals. But with Nitro, Graviton, Inferentia, and Trainium, developers don't have to trade performance for sustainability, but can benefit from higher performance, lower costs, and knowing they're using less energy. AWS will continue to invest in building purpose-built silicon solutions to address the growing compute and machine learning needs of all of our users, striving for a more sustainable and greener future. As you know, at AWS, we are customer obsessed, and we design our purpose-built silicon and services with our customers in mind. I hope these examples shared in this talk will inspire you to think about how AWS's solutions can help you solve your application challenges. But there's no substitute from hearing from one of our customers. So I'd like to invite David, Chief Architect at Pinterest, to talk about Pinterest and AWS are partnering on their sustainability journey. Thank you.
Hello, I'm really excited to be here. Thanks so much for inviting me. And hello to the folks who have gotten this far in the online recording of the talk. Stick with us, please. My name is David Chaikin. I'm the Chief Architect at Pinterest, where I'm a tech lead for development and operations at the company. And most of that is on AWS, whom we've been working with since 2010. So we are a born-in-the-cloud company. For those of you who are unfamiliar with us, Pinterest is a visual inspiration platform people around the world use to shop products personalized to their tastes, find ideas to do offline, and discover inspiring creators. People have saved more than 360 billion pins across a range of interests, from building a home office to cooking a new recipe and planning a vacation. So for example, if you look at the inset in this slide, you can see the Pinterest board that I used to plan a trip to Nepal. And in what I think is a really nice connection to this talk, if you look at the mountain looming behind me at 7,000 meters, that's Annapurna South behind me. At Pinterest, our mission is to bring everyone the inspiration to create a life they love. And today, I'm excited to share a bit about our environmental sustainability journey and our partnership with AWS. So for us, it began for real a few years ago when Mia Ketterling, who was at the time head of our employee community focused on environmental sustainability and the planet, and Charlie Hale, who is our head of global public policy and social impact, came to me and said, hey, we would like to work with AWS to understand our carbon footprint as a company because so much of our product depends on AWS. That was significant for us. And to understand AWS's commitments to achieve net zero emissions by 2040 and 100% renewable energy by 2025. So from these conversations, we understood that it was important for us as Pinterest to track the emissions associated with the rest of our operations. That means our real estate portfolio, our supply chain, our business travel, and so forth. So Mia actually transitioned from being head of the employee community to being a full-time sustainability manager on our workplace team. And she's done a lot of great work in terms of doing the auditing around our carbon footprint as a whole. So I want to share some highlights from this journey so far. And a lot of this is starting to come together this year. So in April of this year, we banned climate misinformation on our platform. So the more than 400 million users who come to Pinterest will see accurate information about the climate on our platform. We relaunched our employee community, which is now 400 people strong, and that's a pretty significant fraction of our user population. And then the other thing we did more recently is we announced that for our own real estate profile, we will be switching over to renewable energy by sometime next year. So all of this was kind of triggered by our partnership with Amazon and really understanding our carbon footprint on Amazon. And so one of the things that we were really excited about this year was the general availability of the carbon footprint tool, which was announced a year ago here at reInvent. And that allows us, and for that matter, any other AWS customer to understand the carbon emissions associated with our footprint or your footprint on AWS. So all of these transitions, a lot of which came together this year, are just steps along our journey towards sustainability and reducing, as a company, our environmental impact and inspiring a better future for everybody. So let me transition to the core topic of this talk, which is AWS Silicon and our experience with it. And we actually wrote all of our material before seeing what Paul and Kamran said, but you'll find that a lot of what we're seeing is directly in line with the numbers that especially Kamran was talking about. So we started our journey with Graviton in about 2021 and put together a proposal based on total cost of ownership and return on investment. And this is really a multi-year program to move a lot of Pinterest systems over to Graviton. From the perspective of me as an architect, it's a really good opportunity to upgrade a lot of our software stack, including operating system, Java virtual machine, and a whole stack of dependencies. I do want to point out that is a tall stack, so that's why it's going to take us a while to move over to Graviton. But what I would say is one thing that was kind of a pleasant surprise this year was we actually got our first production workload moved over to Graviton. So that's just one use case, and it's our caching tier of servers on Memcache. We saw about 40% performance gains, and with the performance advantages of Graviton plus cost, we figure for this one use case alone, we'll probably save about $1 million a year. And that's one of many, many use cases across our infrastructure. We're earlier in our journey with Inferentia and Trainium, but when we look at our initial experience and benchmarks that we're doing with our own workloads, it does align well with the numbers that Kamran presented. So when you come to Pinterest and you look at a screen on Pinterest, we hope that that's a great kind of easy discovery feeling, but underneath there's a lot of machine learning, and in particular recommendation models. And so when you go to Pinterest for any screen, you might be triggering dozens of machine learning models that are each doing inference and rolling up results for you to be able to see. So for those recognition models, we tested them on Inferentia for inference and saw about a 2x benefit in terms of performance. And we also looked at the BERT models that Kamran was talking about. BERT are the transformer language models. They require about an order of magnitude more compute than our recommendation models require. So we're careful about where to use them in our infrastructure. So far, we're using them in the search surface on Pinterest, and our trust and safety team is also using BERT models. And again, when we did the proof of concept for BERT, we also saw about a 2x performance increase. And again, so we expect to see the same kinds of cost efficiency numbers that Kamran was quoting, because it's a combination of both the cost savings on the instances plus the performance. So we're very excited about Inferentia and Trainium and staying on that journey. I want to step back and talk a little bit about the bigger picture. My perspective is that the best way to move towards environmental sustainability is to align the incentives and metrics around cost efficiency and performance, which improves the user experience, and environmental sustainability. So we run fairly often Ask Me Any sessions for engineers at Pinterest, and we get the question a lot, how do I, as an engineer, personally help to reduce Pinterest's carbon footprint? So what we say is to our engineers is, for the most part, the goals of environmental sustainability, reducing the carbon footprint, are well aligned with cost efficiency. And we have great dashboards for carbon efficiency, and engineering tech leads who are called spend captains, who can help track engineers into how they can save money for the company. And for the most part, that is well aligned with reducing our carbon footprint. There's one thing that's not on the slide that I do want to talk about, which is there may be some places where those high-level metrics and goals of environmental sustainability and cost efficiency may not be 100% aligned. So for example, we wrote a blog post saying that we are able to use models this year that are about 10 times or 100 times bigger than we were able to do before, because we ported the training and the inference over to GPUs. And we did that working closely with AWS in a cost-neutral way. And we were very proud of that, because for the same cost, we can provide a much better experience for our users. I think that we, as a company and working with AWS, would like to go back to that and say, yes, but GPUs are enormously power hungry. So there's additional study that we need to do to say, okay, was that cost neutrality exactly aligned with environmental sustainability? And what I'm thinking in this case is it won't be as well aligned as when we get on the train of AWS Silicon, Inferentia, and Trainium. And I think that those new processors that are available for us to use will likely get cost efficiency well aligned with environmental sustainability again. And so overall, as our business grows, we're very focused on all of these different aspects of cost efficiency and performance and environmental sustainability. So a little bit deeper in terms of how does all of this work, I just wanted to talk about the metrics that we use and the time frames that we get those metrics. So when an engineer or engineering team is deploying technology to our AWS-based infrastructure, we have dashboards that show the size of the clusters, the number of instances, the amount of S3 storage you can look up using the AWS API. So engineers on a real-time basis have a pretty good idea of the resources that they're using. Then on a daily basis, we take all of the information from deployments and usage of our infrastructure and pipeline that information into a data warehouse. So more on a day-to-day basis, we can join the resource information with the costing information and give engineers and engineering teams kind of a daily analytics view of what are the costs and how are they changing from day to day. Then on a monthly basis, we get our AWS bill, and we true up the variance of that AWS bill against what we have in our warehouse that represents our infrastructure. And so when we do that join on a monthly basis, then we can get a very precise view of how we're doing on all of the cost metrics. And then finally, through the carbon footprint report, we get that on a monthly basis, but it has a 3-month lag in the data because it requires AWS to join all the information about how their data centers work up with our specific usage. So environmental sustainability is kind of a lagging metric that we get, which is, again, yet another reason why it's important for us to align resource usage and cost efficiency and sustainability, because it takes a while for those sustainability numbers to come through the system. Okay, so I talked about how everything kind of landed this year in terms of the banning of climate misinformation and moving over to green power and the work that we're doing to understand our carbon footprint. Even though we started years ago, it seems like we're almost just getting to the starting line for a lot of what we're doing. But I will say we're dedicated to doing our part to promote sustainable outcomes on our platform within our operations and our communities. So our commitment to renewable energy and the other things that I mentioned in terms of progress are only the first steps in that journey to inspire a better future and create a greener world. And as we continue in this journey, we'll seek like-minded partners like AWS and continue to explore the different win-win scenarios that we can do. And if I leave you with anything, it's we need to align the cost efficiency and performance and environmental sustainability together for us to make really significant progress. And I believe that AWS Silicon will be a big part of that journey going forward. So with that, I'd like to invite Paul and Kamran back up here so Paul can close us out by reviewing some of the upcoming sessions.
So thanks to both of you. for showing us basically how we incorporate sustainable thinking into our hardware and how you develop sustainable software to use that hardware. I think it's a nice story between the two. One thing that you both talked about that I find very interesting, and I think it's worth repeating, is how sustainability and cost can align, right? Mm-hmm. Like at the same time. I think a lot of folks have this idea in their head that sustainability is a cost adder, right? But you've shown, I think really well how that's not the case.
Yeah, I think that these 360-degree wins are really important for making progress and getting everybody across the company aligned to make progress.
Yeah, exactly. And hopefully through those examples we talked about today, this is what we see with our customers a lot of the time is that, they're definitely trying to hit performance and cost metrics, and the sustainability metrics kind of come for free if we're using kind of Inferentia, Trainium, and Graviton. So as you're saying, it's a great kind of combination of these goals.
Yeah, real good story. So if you're interested in other sustainability stories and learning more, there are quite a few other sustainability presentations that are going to be going on for the rest of reInvent. I've got a list here on the screen. There's one actually directly after this at 2:30. I'll give you a chance to take a picture. And then there's a couple here. I think most of those are still happening today and tomorrow. So thanks everybody for coming.